Alright guys, in this video we are looking at the analytic way to find this area. So this is what we found with Desmos approximation of the volume under the surface 5y. It's a plane, and over the region. Our region was -1 to 1 for x, and two functions. The upper one was 2 plus x squared, and the lower one was 3x squared. Within our region. And so what we're going to do is we're going to set that up. -1 to 1 is our x's. 3x squared was our lower y. 2 plus x squared was our upper y. And there's our function to integrate. So this is our, in this notation, our a to b g of x1, g1 of x, g2 of x in the notation that I gave you in the last slide, and this is our f of xy. Alright, so we're doing y first, then x. So dA, that's in general the region you're dealing with, the area, a small change in the area within that region. And this is how we then break that apart. We define the region. So somebody should be able to draw this based on this. -1 to 1 for x's. These x's going in for these x's and these functions. That would create those two parabolas that we saw in the last video. Alright, and then these define these as y's. This differential defines these outers as x. Remember, they're always paired inside and outside. Alright, well, let's integrate. How do I take the antiderivative? What's the antiderivative of 5y with respect to y? Well, it is 5y squared over 2. Add 1 to the power, divide by the new power. Now, these are y's. So we're going to replace y and these things with 2 plus x squared, right, and square that. And then we're going to plug in 3x squared for y and subtract. So when we do that, expanding this 2 plus x squared, if you square that and expand and subtract, you'll get this expression. Okay, and then if I were to take this expression, simplify it, x to the fourth minus 9x to the fourth is -8x to the fourth. Multiply that through, you get -20x to the fourth. Okay, 4x squared, move that through, you get 10x squared. 4 times 5/2 is 10. And so this is our expression that only contains x's from -1 to 1. All right, and then we integrate. What's the antiderivative of x to the fourth? X squared, and just a constant with respect to x. It is x to the fifth, x third over 3, and then 10x. Right? X to the fifth over 5, so we get a -4 there. And now we're just going to plug 1 in for all these x's. So -4, 10 thirds, and 10, and then minus when I put the -1 in. I get that, and then that simplifies to 56 thirds. So exactly what we got, or the approximation that we got with Desmos, there's how we would get it exactly. The only thing that's different from what you've done with integration before is you are actually plugging in expressions into the antiderivative. Okay, this is what we do to x to get the y's between -1 and 1 for x. We do this to get the y's. So I'm plugging that in replace of y and getting this expanded expression in x.